This is my beginning algebra course. Today we're going to solve more equations by factoring. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, in a previous class, we learned how to solve quadratic expressions by factoring, and in those equations, we factored quadratic expressions. In this class, we're going to factor quadratic expressions also, but we're going to use other methods that we learned to factor expressions to solve these equations. So in the first problem, what we're going to do is we're going to, I just want to remind you, when you see an equation like this, it's asking you, find x. When they tell you to solve, it means find what x is. What number can we plug in here that would make all of this equal 0? So that's what it means to solve an equation. So we're going to factor out the greatest common factor, which is 3x, and I know 3x is the greatest common factor because 3 is the biggest number that goes into all these coefficients. It's called the GCF, greatest common factor. And I'm going to factor out the smallest x power, which is x to the first power. And then I'm just going to write what's left after we factor. And if you don't remember the previous classes, you might be thinking, well, wait a second, how did you know that the inside was x squared and then it's 7x and 10? How did you know that? Well, I just asked myself, what expression times 3x is equal to 3x cubed? It's fairly easy to figure that out. If you're going to multiply 3x by something, it's got to be x squared in order to get a cubed. So 3x times what is equal to 3x cubed? So this is just review from the previous classes. So at this point, after factoring out the greatest common factor, we see we have a quadratic expression. So again, this is all review. We've done this before. We've factored these expressions. So now we're going to factor the quadratic expression. What two numbers multiply to 10 and add up to 7? That would obviously be 2 and 5. So we factored this expression completely. And you're probably thinking, well, so what's the big deal? How is this different? Well, this class is different from the class where we factored expressions because now we're setting the expression equal to 0. So in the previous classes, all we were doing is just factoring the expression. We weren't trying to find x. But now that we have an equation and we're setting the expression equal to something, now we're actually trying to figure out what x is. And we're going to use factoring to figure out what x is. And that's why we did all of this work here. We cannot figure out what x is very easily just by looking at this equation. But if we factor, now we can immediately see all the answers just by looking at this expression. So what we have here is a times b times c. You're multiplying three numbers because we have parentheses, which means multiplication. So it's like a times b times c equals 0. So what that means is that either a or b or c, one of these numbers or two of them or all of them have to be 0 to make this equation work. Again, if you multiply a number, for example, like 3 times 0, it has to be 0. Any number multiplied by 0 is 0. So that means that either 3x is 0, and I'm going to do arrows to show that we're breaking the equation into three parts. 3x has to be 0, or x plus 2 has to be 0, or x plus 5 has to be 0. Those are the three possibilities. So if we divide both sides of this equation by 3, we get x equals 0. Subtract 2 from both sides, we get x equals negative 2. Subtract 5 from both sides, and x equals negative 5. So there are three solutions to this equation. And again, the reason that works is because if you plug in 0 here, you get 0 times 3 is 0. And it doesn't matter what these values are going to be. If you multiply 0 times all these numbers, the expression is going to go to 0. If you plug in negative 2 here, negative 2 plus 2 is 0. And this factor is now 0. So it doesn't matter what these other factors are going to be. If you multiply them by 0, it's going to make the equation work. You're going to get 0. And of course, the same thing here. So that's what's going on here. It's very simple. We're using factoring that we learned in the previous classes, and we're solving the equation by using those methods of factoring. So again, the previous class that we did, it was a special type of formula, quadratic formula. But in this class, the expressions that we're solving or those expressions we're working with are much more complicated. All right, so for number 2, it's the same principle. You're going to factor out the greatest common factor, which is 3y. And then you can see that we have the difference of two squares here. You may recognize that as the difference of two squares. That's one of the expressions that we learned how to factor. So we need 2 pairs of parentheses, and then we just square root the 4y squared to get 2y, and then we have a plus and minus. And then we square root 9. So what number times itself is equal to 9? That's 3. What number times itself is equal to 4? That's 2. That's the same. I'm saying square root, but that's what it means. What number times itself is equal to those numbers. All right, so now we break it up into 3 parts. 3y can be 0. 2y plus 3 can be 0. And 2y minus 3 can be 0. And I'm going to divide both sides by 3, and we get y equals 0. That's one of the answers. And I'm going to do 2 steps at once. I'm not going to show the steps. I'm just going to show the result after performing the 2 steps. I'm going to subtract 3 from both sides, and then I'm going to divide by 2. I divide both sides by 2, so I get y is equal to negative 3/2. And over here, I'm going to get y is equal to positive 3/2. So that's another type of problem. So you're going to pull out a perfect square and you're going to get a quadratic expression, or you're going to pull out a perfect square or pull out a. Did I say perfect square? You're going to pull out a greatest common factor, and you're going to get a quadratic expression. And over here, you're going to pull out a greatest common factor and get the difference of 2 squares. So that's 2 situations that you're going to encounter. I don't know why I said a perfect square there. Whatever. All right, so now it's time for you to try. You might need your calculator to figure out how to deal with that 120. So try number 3, and when you come back, we'll do it together. All right, we're back. So the greatest common factor is 4y. And 120 divided by 4 is 30. So again, to check this, you just multiply back. 4y times y squared is 4y cubed. 4y times y is 4y squared. And 4y times negative 30 is negative 120y. So I know that my factorization was correct. So now we have a quadratic expression. So we're going to factor that. What 2 numbers multiply to negative 30 and add up to positive 1? So obviously that's going to be 6 and 5. So now (4y) is equal to 0, or could be equal to 0. Y plus 6 is equal to 0, and y minus 5 is equal to 0, and so on and so forth. That means y is equal to, y could be equal to 0. Divide both sides by 4 to get that. And then y could be equal to negative 6. And then y could be equal to 5. All of these solutions would work. They would make the equation true if you plugged them back in here. You get 0 if you plug them into this expression. So if you got those solutions, good job. So when you pull out the greatest common factor in this problem, you're going to get the difference of 2 squares. So try number 4, and when you come back, we'll do it together. All right, we're back. So they pull out the greatest common factor, and that would be 9x, it looks like. And then you can see we have the difference of 2 squares. So we learned how to factor that in a previous class. So we need 2 pairs of parentheses, put your x, and then what number times itself is equal to 4. Obviously that's 2, and then just put your plus and minus. All right, so now we break the equation into 3 parts because we know these 3 factors are going to give us 3 possible solutions. So if 9x is equal to 0, that would make the equation 0, and if x minus 2 is equal to 0, that would make the equation 0, and if x plus 2 is equal to 0, that would make the equation 0. So now we just add 2 to both sides, and we get x is equal to 2. Subtract 2 from both sides, we get x is equal to negative 2. And divide both sides by 9, and we get x is equal to 0. So if you got those 3 solutions, good job. All right, so let's do number 5 together. We're going to factor out z to the 6th power. So this is a little different because we're factoring out a 6th power, which is that's a pretty high power there. Now we have a quadratic expression. What 2 numbers multiply to 16 and add up to negative 8? That would be negative 4 and negative 4. And now we're going to break the equation into 3 parts. So z to the 6th power could be 0. Z minus 4 could be 0. Or z plus 4 could be 0. So with these 2 equations here, it's just the same situation. It's just z is equal to 4 by adding 4 to both sides. Z is equal to negative 4. So those are 2 solutions. But this part is a little different here. Technically, to solve this equation, you would have to rewrite, and you want to get rid of the 6th power, so we'd have to do something called the 6th root. But we haven't learned how to do that yet. I just want you to understand that if you have a monomial term here, it really doesn't matter what the term looks like. For example, you could have 3z to the 6th power. It doesn't make a difference, because if z is 0, that's going to make the entire monomial 0. You might have negative 2z. You might have negative z. You might have 10 times z. It doesn't really matter what the monomial is. If you plug in z to all these expressions, if you plug in 0 for any kind of monomial term, it's going to make the term 0. So we haven't really gone over 6th roots yet, but you don't really need to know how to do 6th roots, and it's not really difficult to do 6th roots. It's just we haven't gone over it yet. So all you need to know is that z is just going to be 0 for all these monomials. Whenever you have a monomial term, this first term, it just means one of the answers is going to be 0. So you don't really have to do any complicated math to solve that. Just write the variable is equal to 0 and get rid of that power. So that's the way it's going to be on pretty much well, most of the problems in this class, not all of them. All right, because some of these problems won't have monomial factors. So let's do this problem together. We have the same situation. We're going to pull out 2, it looks like, 2y squared. And the difference is we have a squared term here in the monomial. So that looks correct. And you see here we have the difference of 2 squares. So I'm now going to factor the difference of 2 squares. What number times itself is equal to 25? What number times itself is equal to 64? So, again, 2y squared, we're going to set that equal to 0. We're going to set 5y minus 8 equal to 0. And 5y plus 8 equal to 0. So this is the strange part here. But again, it really doesn't matter what this expression is. If you have a monomial term, y is always going to be equal to 0. That would make the monomial 0, which would make this entire equation 0, because if you multiply 0 times whatever these numbers would be, you're still going to get 0, which would make the equation work, which means this is a solution. And then, of course, we're going to do two steps at once, and we get y is equal to 8 over 5, and y is equal to negative 8 over 5. So there's three solutions again. All right, so again, the only difference for these two problems was that you had weird terms, weird monomial terms. But again, it really doesn't matter. The answer is just going to that just means the answer is going to be one of the answers is going to be 0. All right, so time for you to try. Go ahead and attempt number 7. And when you come back, we'll do it together. All right, we're back. We're going to pull out 6x squared. And let's just double check by multiplying back using the distributive rule. It looks right. Now we have a quadratic expression, so we're going to have to keep factoring. What two numbers multiply to 2 and add up to 3? Obviously that would be 1 and 2. So now we couldn't see the solution here, but now that we've factored, we can see the solution, or the solutions. If we set 6x squared equal to 0, that'll work. If we set x plus 1 equal to 0, that'll give us a solution. And if we set x plus 2 equal to 0, that'll give us a solution. So again, it doesn't matter what this expression is. We know x is just going to end up being 0. That'll make that equation work. So if you got these three solutions, good job. All right, so for this problem, don't try this problem yet. I think I need to modify this a little bit. I'm going to make this a 4th power, and I'll make this a 2nd power. So now try number 8, and when you come back, we'll do it together. All right, we're back. So we're going to pull out a 4y squared. And then we have the difference of two squares. That might not look like the difference of two squares, but it is, because 1 is a perfect square. So what number multiplied by itself equals 4? That would be 2, obviously. What number multiplied by itself equals 1? That's 1, so we need plus 1 and minus 1. All right, so we've factored it completely, and the factorization allows us to see the solutions. That's why we're factoring, because it allows us to see the solutions very easily. So we just solve these equations, and we get y is equal to 1/2, y is equal to negative 1/2, and of course y is equal to 0. Maybe I should put a divider here. Well, I guess I don't need one. So if you got those solutions, good job. Negative 1/2, positive 1/2, and 0. All right, so let's do number 9 together. Number 9 is a little different just because we need to factor out a negative also. If you don't factor out a negative in your greatest common factor, the problem is going to be more difficult. So we're going to factor out, let's see, I think 4 will be the greatest common factor, and x to the 6 is the smallest power. So then we're left with 3x to the 2nd plus x minus 2. I think that's correct, but I'm not sure. I got to multiply using the distributive property going backwards. So negative 4x to the 6 times 3x squared is negative 12x to the 8. That works. Negative 4x to the 6 times x is negative 4x to the 7th. That works. And negative 4x to the 6 times negative 2 is equal to positive 8x to the 6th. So it looks like that all works. All right, so now we have a quadratic expression, but just be careful, be very careful, because we have a coefficient in front of the squared term, so that's going to make it a lot more difficult to factor it. Because now, instead of x and x, we're going to have x and 3x. That's going to complicate things. And please, please don't forget to write your equals 0. You need to write equals 0 in every single step, because you have to keep your equation. If you get rid of the equals 0, then all of a sudden you're not dealing with an equation anymore. You're dealing with an expression, and now we don't know what in the world we're doing. So what two numbers multiply to -2? I'm going to say -1 and +2, and that's really the only option. But we don't know if the 3 goes here or here, so we have to FOIL. Again, we do ask what two numbers multiply to -2, but we don't ask what two numbers add up to 1, because the 3 complicates things. So we're going to FOIL back out, but we only need to use O and I of FOIL. So O of FOIL is 2x. I of FOIL is -3x. You put these together, 2x minus 3x, you get -x. Okay, bingo. We got the right number, we just got the wrong sign. So we just have to switch the signs. All right, so we factored correctly. And now that we've factored, we can see what the solutions are going to be. And again, you don't have to set these all equal to 0. Well, actually, it probably would be best to set them to 0, because this is a two-step equation, so it's probably good to at least write that so you know what's going on. So again, we don't care what this monomial term is. It just means that x is going to be 0. And x equals -1. And this is a two-step equation. Add 2 to both sides, divide by 3, you get x is equal to 2/3. So -1, 2/3, that looks correct. All right, so on to the next problem here. So again, the difference here is that we have to factor out a negative. We don't want a negative on the first term. And by the way, you might have, I didn't really explain yet, how did I know to factor out a negative? Well, because there's a negative on the first term over here. You don't want a negative on the first term. So if you see a negative on the first term, you want to factor out that negative. So on to the next problem. You see that we have a negative on the first term. Whenever you have a negative on the first term, you got to factor out that negative, or else the problem is going to be a lot more difficult. So you take out that -2, and you have x squared minus 16. So how do I know that? Well, if I just multiply back, I get this expression, and I know I did it correctly. So now we're going to factor, and we get -4 and +4. So again, this is the difference of two squares. So we've learned how to factor that. Whoops. Now this is different. This situation is very different. So I need you to pay attention here. Be aware of what's going on. This is a different situation. So as usual, we have x plus 4 is equal to 0, and we just solve, and we get x is equal to -4. No difference there. We also have x minus 4 is equal to 0, and add 4 to both sides, we get x is equal to 4, no difference there. But there's a big difference when it comes to this term here. Notice that this term does not contain an x. So what that means is there's no third answer here. If there's no x there, then obviously we can't plug in an x somewhere here to make this expression 0, which is what we want. So if you plug in 0, it's not going to make this equation 0. So there's no third solution on this one. So just be aware of that. If your monomial contains a variable, then one of the solutions is 0. But if it doesn't contain a variable, it's just like -2, for example, then 0 is not one of the solutions in these type of equations. So there's only two solutions, -4 and +4. So again, if you see these problems where you have a negative in the coefficient on the first term, you have to factor out a negative. So try number 11, and when you come back, we'll do it together. All right, we're back. So we're going to factor out I think we're going to factor out a -2, -2z. So then we're going to factor that quadratic. And again, this is more difficult because we have the coefficient on the squared term. I'm going to try -6 and -5. I have no idea if that's going to work. So we get the O of FOIL is -18z. The I is -5z, so we get -23z. So that doesn't work. So we're going to switch the 5 and the 6. And then we get -21, which is not correct. So let's see. Looks like 6 and 5 are not going to work. That's okay. We can try something else. Let's try 10 and 3. So then the O term is 9z, and the inside term is -10z. Excuse me, -9z and -10z. So we add those up and you get -19z, which is what we want. So we factored it correctly. So now that we factored it, we separate as usual. So again, the only difference for these problems is that you have a negative that you have to factor out, because the leading coefficient has a negative sign. And it just makes it easier. You don't really have to factor out the negative, but again, it just makes it so much easier to solve. So in my course, I want you to factor out that negative. So z is equal to 0. Doesn't matter what that monomial looks like. As long as it has a variable, you're going to have one of the answers is going to be 0. And a two-step problem, so we end up with z is equal to 10 over 3. And z is equal to 3. So if you got those answers, good job. So now you try number 12. Again, there's a negative on the leading coefficient, a minus sign, so you're going to have to factor out a negative. So try number 12, and when you come back, we'll do it together. All right, we're back. We're going to factor out a -5z squared. And then we're going to factor the difference of two squares. Just like we learned in previous classes. And that tells us that there are 3 solutions. All right, so we have +2, -2, and 0. So if you got those answers, good job. On to number 13. So now We have another problem with the leading coefficient of, with a negative sign, so go ahead and try number 13, and when you come back, we'll do it together. All right, we're back. We're going to factor out negative 2 x to the 4th, it looks like. Whoops. I think that's correct. Let me double check. Multiply back. And that looks correct. So we have a 9 on the squared coefficient, so it's going to make it a little bit more difficult to factor. So I'm going to try 3x and negative 2 and positive. Well, actually, that's not going to work, because that would give us the difference of 2 squares. So I'm going to try negative 4 and positive 1. So O of FOIL is 3x. Again, we only have to check O and I of FOIL. We don't have to check F and L. And I of FOIL inside is negative 12x. And 3x minus 12x is negative 9x. So I got lucky. My first try was correct. So that's the correct factorization. And so we break it up into parts, into equations. And of course, the monomial just tells us that x can be 0, because if you plug in 0 to any monomial, as long as there's an actual variable to plug it into, it's going to make the monomial 0. X is equal to 4/3, and x is equal to negative 1/3. So if you got those answers, good job. All right, so we're just going to do a bunch of these problems for you to get more practice. We're going to do 1, 2, 3, 4. We're going to do 4 more of these problems, and then we're going to go on to something else. So try 14, and when you come back, we'll do it together. All right, we're back. Factor out 7y cubed, and you get 2y squared plus 7y plus 6. So this is a quadratic expression, so we have to factor that quadratic. I need to check to see if I factored out that common monomial correctly, though. Looks like I did. So rewrite your monomial. And by the way, I want you to write your work exactly the way you see me write my work. So I'm going to try this factorization, see if it works. I don't know if it's going to work, but we'll see. O of FOIL is 4y, I of FOIL is 6y, 4y plus 6y is 11y. That's not 7y, so that didn't work. So let's try, oh, whoops. You know what, I just realized I didn't factor that correctly. That shouldn't be a 2y, that should just be y, I'm sorry. So now let's try 4y and 3y is 7y, so that's the correct factorization. All right, so now we can break it up into 3 parts. And so if you got those answers, good job. So try number 15, and when you come back, we'll do it together. All right, we're back. So we're going to factor out 5y squared. multiply back in the opposite direction to see if we did that correctly. Looks like we did. Now we have a quadratic expression. And now we can break it up into 3 equations. And y is equal to 0, y is equal to 2, and y is equal to negative 4. So if you got those answers, good job. Try number 16, and when you come back, we'll do it together. All right, we're back. Factor out a z squared, and you're left with the difference of 2 squares. This is the difference of 2 squares. So we can factor that. What number times itself is equal to 81? Obviously that's 9, and you put your plus and minus. Again, we learned how to do this in previous classes. I'm going to move that over a little bit. So break it up into 3 equations. So if you got those solutions, good job. This again, this monomial just tells us that z is going to be equal to 0. So if you got those solutions, awesome. All right, so looks like we have one more of these types of problems. So try number 17, and when you're done, we'll go on to a different type of problem. All right, we're back. So we're going to factor out 5y cubed. I'm going to see if that factorization works. We got to use the O and the I of FOIL. O is 2y and I is negative 5y. So I got lucky, it worked. Add them together, you get negative 3y. So if you got those answers, good job. So now we're going to go on to factoring by grouping. Again, we learned how to factor by grouping, but we didn't set the expression equal to 0. So in other words, we learned how to factor by grouping, but we didn't actually learn how to use it for something. Now we're using it for something, just in the same way that we learn how to use these previous types of factoring to solve these equations. We factored out a greatest common monomial, greatest common factor, and we factored a quadratic expression, and we factored the difference of 2 squares. We use all those factoring methods to solve an equation. So now we're going to use factoring by grouping to solve an equation. Again, the only difference is we have it equal to 0, which means we're finding x. So to factor by grouping, you're going to take this group and factor out a greatest common factor, and you're going to take this group and factor out a greatest common factor. So we're going to factor out x squared, that's the greatest common factor in the first yellow group. And then we're going to factor out a -4 in the blue grouping. And the reason that I suspect that I did this correctly is that we have, actually I didn't do it correctly. I need to change this. I didn't do this right. See that? That should just be an x. See, I checked it, and I saw that it was wrong, so that was a good indication I did something incorrectly. But now I suspect it's correct because we have a x plus 10 factor in both the terms. But you do need to multiply back in both these situations to figure out if you did it correctly. X squared times x is x cubed. X squared times 10 is 10x squared. -4 times x is -4x. -4 times 10 is -40. So we got these terms in each case, so it works. All right, so now you see we have x plus 10 and x plus 10 as a common factor. So we can factor out the x plus 10 from both of these terms. Whoops, x plus 10 that should be. And we're left with x squared minus 4. Again, this is just review. If you're confused by this, that probably means that you didn't do the homework or you're just a little rusty. So if you want to go back and look at the class on factoring by grouping, you're more than welcome to do that. Don't be afraid to do that if you need to. All right, so now you see we have the difference of two squares here, so that's kind of important. Maybe I should color that purple. I don't know if these colors are going to confuse you or help you or what, but I'm just going to keep them there. All right, so now we're going to factor. We haven't factored completely simply because we have the difference of two squares. We have to keep going with that green part. What two numbers multiplied, or what number multiplied by itself rather, is equal to 4? That would just be 2, and then put your plus and minus. So again, we factored this expression by using factoring by grouping. Now, one really important thing to understand is how do you know to use the method of factoring by grouping? Well, there's going to be 4 terms. In all these problems, you're going to have 4 terms. And that's going to tell you that you're going to use the method of grouping. In the previous problems, we either had 2 terms or we had 3 terms. If you have 3 terms, it's going to be a quadratic. If you have 2 terms, it's going to be the difference of 2 squares. And if you have 4 terms, it's going to be factoring by grouping. So that's how you figure out what method to use. All right, so this factorization tells us that, well, it tells us what the solutions are. So we just do the exact same thing that we did in the previous problems. No difference whatsoever. So we have -2, 2, and x is equal to -10. So those are the 3 solutions. I guess there is a difference because this term is not a monomial anymore. We got 3 binomials instead of 2 binomials and a monomial. But it's not really that important. So 2, -2, and -10. So also be aware that sometimes factoring out a negative is kind of confusing to students. So be careful about that. It looks like you're going to have to factor out a negative here also. So go ahead and try number 19. And when you come back, we'll do it together. All right, we're back. Pull out the x squared in the first 2 terms. And pull out a -9. In the second 2 terms. And I just realized I didn't use the same coloring scheme that I'm using here, so don't be confused by the coloring scheme here. So now we're going to factor out an x minus 5, because we have an x minus 5 that's common to both terms, and we have x squared minus 9. And I'm just going to move that over so the equal signs are right below each other, or lined up. So this is the same type of situation. We have a binomial, and we have the difference of two squares, which is also a binomial. So we're just going to rewrite the x minus 5. We can't do anything with that, but we can factor x squared minus 9 to x plus 3 and x minus 3. So now, again, just break it up. I don't need to tell you how to do this because you've done it, 20 times already today. So if you got those answers, good job. All right, looks like we're going to have to, let's see. Well, we're going to do this one together. We'll see what happens here. So I'm going to factor out a greatest common factor in those terms there. So that would be 4y squared. I'm going to factor out a negative 1. And I'm just going to double check, multiply back to see if that's correct. And it looks like it's correct. So you can see that we have, I'm going to choose this coloring scheme here because I think that helps. We have y plus 3 as a common factor, so we'll just pull out y plus 3. And we have the difference of two squares. So what number multiplies by itself to get 4? That would be 2. And what number multiplies by itself to get 1? That would just be 1. Again, 1 is a perfect square, just like 4 is a perfect square. So now we're just going to break it up into 3 equations like normal. Y is equal to negative 1/2. Y is equal to positive 1/2. And y is equal to negative 3. All right, so why don't you try number 21, and when you come back, we'll do it together. All right, we're back. Pull out the perfect square in the first, actually I'm going to make the first term yellow. So that'll be 4x squared. Pull out negative 9. And I'm just noticing that all these problems we're having to pull out a negative in this second grouping here. That's just a coincidence. You don't always have to pull out a negative. So I'm going to give you some other problems where you don't pull out a negative because I want you to see that sometimes this is going to be a positive. All right, so we're going to go backwards and multiply to make sure that we did the factoring correctly so far. 4x cubed, 16x squared, negative 9x. That looks correct. So now we're going to factor out an x plus 4 because x plus 4 is common to both of these terms. And we get 4x squared minus 9 left over. 4x squared minus 9. And now we have the difference of two squares. right. Whoops, I didn't realize I forgot to put my arrows on these. Sorry about that. X is equal to -4. X is equal to 3/2. X is equal to -3/2. So if you got those answers, good job. So let's try 22 together. In this problem, we're going to have a positive in between the two groupings, so this is good. I want you to see all different types of these problems here. So we're going to factor out in each grouping. Looks like that's correct. I'm going to color code my groupings here. So you can see now we have a positive in between here, because we didn't have to factor out a -4, we only factored out a +4. Again, the way that you can figure out whether or not you did it correctly is by looking at this this common factor. It's x plus 4. We have an x plus 4 in both terms, which means we did it correctly. Now, don't get ahead of yourself right here, because this is going to be something different. I need to explain something very important when it comes to your success in doing the homework. So notice that we were left with x squared plus 4. X squared plus 4. This is not the difference of two squares. This is the sum of two squares. You can only factor the difference of two squares. You cannot factor this because it's the sum of two squares. So let me show you why you cannot factor it. So we're going to break this up into two equations, because there's only two binomials. And so x equals -4. So that's just an expression that we've seen many, many times. But look what happens if you try to solve this equation. If you put the 4 on the other side, you get x squared is equal to -4. Do you see a problem here? Think about that. X squared is equal to -4. Now, we learned in a previous class that what we have to do is we have to square root both sides. And that's how we would proceed, plus or minus. But before we even do that, do you see a problem here? Do you see this? Do you see anything here? Is it possible to square a number and get a negative number? In other words, you take a number and multiply it by itself and get a negative? Is that possible? No, it's impossible. Because let's say that x is 2. Then you plug it in here, and 2 times 2 is +4. All right, so now let's try -2. Let's say that x is -2. So then you plug it in here, -2 times -2, because that's what raising to the second power means. You're multiplying it by itself. -2 times -2 is not -4, it's +4. So it doesn't matter if you put a positive here in this number or a negative in this number. It can't be squared to result in a negative number. So x squared cannot equal -4. So this does not lead to any solution that would make there's no x value that would make this factor 0, which means this does not lead to any answer because it's the sum of two squares. So when you have the sum of two squares, you really don't need to write any of this part here. You can leave it off. You can write it if you want, but at the very end you have to say x squared does not equal to a negative. So why don't you try number 23? That's the same type of problem, and see if you can figure out how to do that, and when you come back, we'll do it together. All right, we're back. So we're going to factor out 5a squared in the first grouping. Actually, no, we cannot factor out 5a squared. We're just going to factor out a squared. And then we're going to factor out 7. And I'm going to have to go back and check to make sure I did that correctly. Always go back and check. (5a cubed) negative 4a squared, 35a. That looks correct. So again, notice we have a plus sign here because we didn't have to factor out a negative 7 from this second grouping, the blue grouping. So we know that we did that correctly because we have a common factor, 5a minus 4. So we're going to factor out the 5a minus 4. And we're left with a squared plus 7. Now you see this? This is not the difference of two squares. It's the sum of two squares. So we really don't need to do anything with this factor. It's not going to lead to a solution. We can just say that 5a minus 4 is equal to 0. And that will lead to a is equal to 4/5. And again, we're not showing the steps here. We're just showing the result after performing those steps because we're getting to advanced math, and when you do advanced math, you don't show every single step. All right, so if you got that answer for 23, good job. Now let's go on to 24. So in number 24, you're going to have to factor out a negative here. So let's just do this one together. We're going to factor out a 5z squared and a negative 1. And that looks correct. So then we factor out a z minus 7 from both terms, and we're left with 5z squared minus 1. Now something different is going to happen here. This is going to be slightly different from what we were doing before. So we're going to break it up into two equations as usual. Well, in this case it would be 2. Sometimes it's more than 2. So now we solve this equation, no big deal, it's just a one-step equation, but in this equation we have an equation with a square. So we learned how to solve equations with squares in a previous class. What you do is you isolate the square, that's the first step, so I'm going to add 1 to both sides and then divide by 5, and I get z squared is equal to 1/5. So we isolated the square. The square was not isolated because the 5 was next to it and the negative 1 was next to it. But now we got rid of those numbers by adding 1 to both sides and dividing both sides by 5. And now we just have to square root both sides of the equation. And I guess I'm going to go ahead and try to show that. So you square root both sides as we learned. Kind of running out of room here as you can see. And don't forget to put your plus and minus. So the final answer is z is equal to root 1 over 5, but we have to rationalize the denominator. Now I'm not going to show you every step to rationalize the denominator, but you're going to end up with root 5 over 5. If you forgot how to rationalize denominators, go back to my class on simplifying expressions with square roots. It's the part 2, I believe, where I show how to do that. So again, in one of these problems, you're going to have to solve an equation with the square, but that's okay because you've already done that multiple times in this course. So try number 25. That's going to be a similar problem, and when you come back, we'll do it together. All right, we're back. I forgot to color code on the previous problem, but I don't really think I need to do that much at this point. I think you get the idea. Go back and check to make sure you did it correctly. It looks correct. Factor out x minus 15. So it is true that this is the difference of two squares, but it's not easy to factor. So we're just going to have to treat that as as an equation with squares. So x is equal to 15. That's the easy part. But over here, we're going to have to isolate the square. So we add 3 to both sides. Now the square is isolated. So after the square is isolated, we learned that when we have an equation with squares, after the first step, isolating the square, we square root both sides. To get rid of that 2 power. And then we have x is equal to plus or minus square root 3. So if you got those answers, good job. Now if you had trouble with this part, that's okay. Just make sure you understand it now, because that was kind of a curveball I threw you on that one. All right, so now we're going to go to some different problems here. Let's try number 26 together. First of all, we have a leading coefficient that's negative, so we have to factor out that negative. So the greatest common factor is going to be negative 2x, I believe. And let me go back and check that, make sure I did that correctly. I did not do that correctly. There shouldn't be a 3 there. So you got to go back and check. You got to make sure you do it correctly. Actually, this is completely wrong. I'm sorry about that. Looks like I can't pull out a 2. You see? Sometimes you just sometimes you do it incorrectly. I got to start all over. Sorry about that. Looks like we can pull out a negative x, and that's about it. If first you don't succeed, try again. So let me double check that. So that looks correct. All right, so now here's what's different. This is not it's not a typical quadratic expression, because we have a 4th power and a 2nd power. Now remember, we did these types of problems. 1/2 of an entire class that we did was these special types of problems. So let's review how to do this. So we're going to need 2 pairs of parentheses. It's going to be like solving a quadratic. Instead you're going to have an x squared and an x squared, rather than just an x and an x in the first terms. And we have a 2, so it's got to be 2 times 1. And I'm going to try, what 2 numbers multiply to 44? I'm going to try negative 11 and positive 4. So now I have to do the O and I terms of FOIL. O is going to be 8x squared. Maybe I should write that. And I is going to be negative 11x squared. So it looks like that's going to work, because you combine those and you get negative 3x squared. Actually, that doesn't work. We want positive 3x squared. Be careful not to do what I just did and look up here. We don't want this. We want the positive 3x squared here. So that's okay. All I have to do is just change the sign. So this becomes positive 11 and this becomes negative 4. All right, so I'm going to get rid of all this. Now I have the proper factorization. So let's break this up. This is going to be some interesting stuff here, so we got to pay attention to what we're doing. So negative x, that's a monomial. We're going to set that equal to 0. And of course, that just means x is equal to 0. Whenever you have a monomial with a variable in it, it just means x is 0. And here we have 2x squared plus 11 is equal to 0. I'm going to solve that, and we have, oh no, I just remembered. I'm sorry about that. My fault. this is a difference of two squares, so we have to factor that. What two numbers? What number multiplies to itself to get 4? That would be 2, and then it would be plus or minus. Remember that? That's the difference of two squares. So that's the difference of two squares. But this expression here is not the difference of two squares. It's the sum of two squares, and so we don't really have to deal with that. But again, let's just to demonstrate what's going on. Let's go ahead and break it up. It looks like we're going to have 4 sections here. So a lot going on. Negative x is equal to 0, just like I said before. 2x squared plus 11 is equal to 0, just like before. And x minus 2 would be 0. And x plus 2 would be 0. So a lot going on here. So x is equal to 0. Again, it's just a monomial, so it means x is 0. And over here we have x is equal to 2, no big deal. Over here we have x is equal to negative 2, no big deal. But this is the factor that's going to cause us some confusion. You need to understand this, or else the homework is going to be, well, it might be difficult for you. So if we put, this is an equation with the square. If we put the 11 on the other side, and then divide by 2, I'm going to do that all in one step. We get x squared is equal to negative 11 over 2. But again, that's impossible. It's impossible to square a number and get a negative. So that's impossible, and you just write not equal to. It can't be true. So that doesn't lead to any solution. So that's what's different about about that particular type of problem. So I'm not really sure what's going to happen in the next problem. You may encounter something different, you may not, I don't know. But just try it, see what you can do, and then if you get stuck, we'll do it together. All right, we're back. So I'm going to factor out a 4z cubed. And we get z to the 4th plus 11z squared. And then 112, I'm going to get my calculator out for that one. 112 divided by 4 is equal to 28. Let's double check before we go ahead here. That looks right. And remember, it's got to be z squared because you have a 4th power and a 2nd power instead of a 2nd power and a 1st power. Plus 7 and plus 4. This is going to be an interesting situation here, because notice that these are both the sum of two squares. This is the sum of two perfect squares, and this is the sum of a perfect square and a not so perfect square. But they're still the sum of two squares, not perfect squares, but the sum of two squares. So because they're the sum of two squares, they're not going to lead to answers. But let's go ahead and just demonstrate what I mean so you can see what's going on. All you have to do is write your answers. You don't really have to show, you have to show this part, but you don't have to show this part if you don't want to. So z squared is plus 7 is equal to 0, and z squared plus 4 is equal to 0. Put the 7 on the other side, you get z squared is equal to negative 7, which is impossible, and over here you get z squared is equal to negative 4, which is impossible. So we rectangle this one, but we do not rectangle these because they're not answers. Again, if you have the sum of two squares, they don't lead to answers. They have to be the difference of two squares. Then they're going to lead to an answer. And if you have a difference of two perfect squares, then you can factor it as we did here. We can continue to factor it. And if you have the difference of two squares that are not so perfect, like z squared minus 7, then you would have to treat it as an equation with squares. I know this is a lot to take in, but just do your best. All right. Let's see here. On to number 28. So we're going to do 28 together. Factor out a greatest common factor. And so the difference here is that we have z to the fourth minus 1. So this is just like the difference of two squares. In fact, it is a difference of two squares. But instead of z and z, you're going to have z squared and z squared. And what number times itself is equal to 1? That would be 1. And of course, you put your plus and minus. Now, this is a perfect example of what I was just talking about over there. You have to look at this stuff and analyze what's going on here. This is obviously going to lead to a solution 0. This is the difference of two squares, which means we can keep going. We can keep factoring this. But this we cannot keep factoring because it's the sum of two squares. So I'm going to keep going. I'm going to factor this inner part. And I'm going to go ahead and color code that so you can see exactly what's going on. But let me just write it first. So this part becomes z minus 1, z plus 1. And this part just is rewritten. And of course, this part is the greatest common factor. So, so this is not going to lead to a solution, but let's go ahead and demonstrate what's going on here. 5z cubed we're going to set to 0. Z minus 1 we're going to set to 0, so on and so forth. Just the same thing we were doing before. And z squared plus 1 we can set to 0. Alright, so I don't really have much room here. Sorry about that. We'll just go down here, and z equals 0. That's the case whenever you have a monomial greatest common factor with a variable. Z equals 1, z equals negative 1, so on and so forth. And over here we have z squared. Oops, I gotta move that down a little bit. Z squared is equal to negative 1, which is impossible. So that does not lead to a solution. So why don't you try number 29? And when you come back, we'll do it together. All right, we're back. Factor out 3x squared. Looks like that's going to be the greatest common factor. And we have the difference of two squares, but instead of x and x, it's going to be x squared and x squared because we have a fourth power. What number times itself is equal to 16? That's 4. And we have the same situation. We have the difference of two squares, and we have the difference, or the sum of two squares. The sum of two squares is not going to lead to an answer. Oh, whoops, I have to keep factoring there. I'm sorry. Keep jumping forward. So the difference of two squares we can factor. What number times itself is equal to 4? That would be 2, and then we just put our plus and minus. I'm going to have to move this over a little bit. And looks like that's correct. So we're going to break it into a bunch of different equations here, as usual. 3x squared can be 0. X minus 2 can be 0. X plus 2 can be 0. And I'm going to have to move all this over. Sorry about this. And x squared plus 4, if that equals 0, then we have another solution. But of course we know that's not going to lead to a solution. So x can be 0, x can be 2, x can be negative 2, and x squared cannot be negative 4. That's impossible. So we have 3 solutions. So if you got those 3 solutions, good job. All right, on to number 30. So number 30 is different because in all the previous problems, the terms were all written on the same side, and one side of the equation was 0. But in these equations, the terms are not written all on the same side, and we can't use our method of factoring unless we put everything on the same side. So in these types of problems, you got to start by putting everything on the same side of the equation. Again, our methods that we learned will not work unless we put everything on the same side of the equation. So I added 2x to both sides, and that canceled this out. It became 0. And over here I just added the 2x. So now that everything's on the right side, we can go ahead and solve. No big deal. So there's not really a huge difference with these problems. The only difference is you have to do that first step. So we factored out the greatest common factor. This is like the first problems that we did. And now we have a quadratic expression, so we're going to factor that. And 2x is equal to 0. X plus 1 is equal to 0. And x plus 1 is equal to 0. But again, that's just going to lead to this to the same answer, or a duplicate answer. So again, it's the same type of problem that we were doing before. It's just we had to do that initial step. No big deal. So why don't you try, actually no, we'll do 31 together because that was a quadratic. In the next problem we're going to have the difference of 2 squares because there's only 2 terms. So the best way to do it is put this on the right side of the equation, so I'm going to do it that way. So I'm going to subtract 72x squared from both sides of the equation. And what that's going to do is it's going to cancel that out, and then I'm going to end up with negative 72x squared on this side. So now I have to factor out a greatest common factor, which would be 8x squared. And you can see that I'm left with the difference of 2 squares, so I got to keep going. So again, the only difference with these problems is that I had to put everything on one side first, then I had to solve. And of course we just, the difference of 2 squares, that's going to be x plus 3 and x minus 3. This is all stuff that we learned in previous classes. So now we break it up. X is equal to negative 3. X is equal to 3. So negative 3, positive 3, and x equals 0. All right, so now time for you to try. Again, the only difference is we have to put everything on one side of the equation first. No big deal. I just want to tell you that it's going to be easier to put everything on the left side of the equation here. You can put everything on the right side, but you're going to have to factor out a negative 1. And also, I want you to be aware that when you factor, it's going to get, it's up to you to figure out what the order of the terms has to be. Notice that I put the terms in descending order of powers. I got third power, second power, first power. You need to do that. If you don't do that, you're not going to be able to factor these problems properly. Over here we had fourth power, second power. Again, it has to be descending order of powers. That's especially true when you end up with a quadratic and you have 3 terms here. You can put it on the left side or you can put it on the right side. Again, I told you the left side is going to be easier because the leading coefficient is going to be positive. But whatever you do, you have to write the powers in descending order, or else you're not going to get, you're not going to be able to factor it. It's not going to look right. This expression would have looked like, if I didn't put it in the right order, it might have looked like 2x plus x squared plus 1. What in the world does that mean? We wouldn't be able to recognize that as a quadratic. So you got to put your terms in descending order of power. So try number 32. Put all the terms on the left side, and make sure you write your 0 on the right side. Write the terms in descending order of powers and factor out a greatest common factor and factor the quadratic expression, and when you come back, we'll do it together. All right, we're back. So we're going to put everything on the left side. And we put everything on the left side by adding 8x to the 6th power to both sides, and that would make this disappear, and that would end up over here. And we subtracted 35x to the 5th from both sides, and that would make this disappear, and it would end up over here as a negative. So when you put things on the other side, the signs basically just change. So this was a negative 8x to the 6th, it became a positive, and this was a positive 35x to the 5th, and it became a negative 35x to the 5th. All right, so now we're going to factor out an x to the 5th. This looks like a weird quadratic here. Let's go ahead and do it. We have 3x and x, and let's try negative 5 and positive 7. O of FOIL is going to be 21x, I of FOIL is going to be negative 5x. 21x minus 5x is not 8x. So let's try switching the numbers. Put the 5 here and the 7 here. O of FOIL is going to be 15x, and I of FOIL is going to be negative 7x. 15x minus 7x is 8x, so that worked. So now we just like usual, we break it up into the different equations. Kind of running out of room here, so I'm going to move that down a little bit. X equals 0. X equals 7/3. X equals negative 5. And there you go. So if you got those answers, good job. Now in this problem, we're going to end up with the difference of 2 squares. So it's going to be similar to number 31. So again, and I should mention, if you had problems with this, you probably didn't write these terms in descending order of powers. You have the 7th power, 6th power, and 5th power in descending order. If you switch some of these, let's say you put the 6th power first, and then the 5th power, and then the 7th power, when you factor out a greatest common factor, your resulting expression is not going to look like a quadratic, or the result after you pull out the perfect square, or not the perfect square, the greatest common factor. So you can put everything on the left side, or you can put everything on the right side. Let's see here. I'm going to try. The easiest way is to put everything on the left side, because if you put everything on the right side, you're going to get a negative. But when I do this problem, I'm going to just go ahead and put everything on the right side just to show you how you would solve it. So, but you can try to put everything on the left side if you want. And again, you have to write the third power first and then the first power, or else it's going to be really confusing. Actually, in this problem, I don't even think it matters what order. It would work either way. But try 33, and when you come back, we'll do it together. All right, we're back. So I'm going to put the 20x cubed on the right side, so it becomes negative. Again, this is not the best way to do it because we would prefer not to have a negative in the leading coefficient. So I just subtracted 20x cubed from both sides. And now I'm going to, because we have a negative leading coefficient, we have to factor out a negative 5x. So I'm just going to multiply back and make sure I got that correct. And it looks like it's correct. So now you can see we have the difference of two squares, so we have to factor that. Whoops. So, same situation. And x is equal to 0. X is equal to 3/2. So if you got those solutions, awesome. All right, so on to the next problem. Now you can see that we have 4 terms. 1, 2, 3, 4. So that means this is going to be factoring by grouping. But again, we have to get everything on one side of the equation. The easiest way, and by the way, if you put everything on the left side of the equation here, then you wouldn't have to factor out that negative, so that's the difference. But you still need descending order of powers, third power, first power. So over here, it doesn't matter if you want to put it on the left side or the right side. Well, actually, in this case, it would be really, really better to put it on the left side. So I'm going to require you to put everything on the left side. Again, we want to keep that positive coefficient. If I put this highest power on the right side, it's going to end up being a negative. So we want to stay away from that. So we're going to put everything on the left side of the equation. And again, I have 4 terms, so I know this is going to be factoring by grouping. So I subtracted x from both sides, that got rid of that x, and we ended up with a negative x on the left side, and I added 2 to both sides, and this went away, and we ended up with a positive 2. So the signs just change when you put stuff on the other side of the equation. So now, again, we just factor this group and we factor this group just like we did in previous problems. But we're going to have to factor out a negative on this group, just so you know. All right, so we're going to factor out an x minus 2, and we have x squared minus 1, and everything is just the same. No difference. The only difference is we have to do that initial step. But this is good practice, so you need to do these problems regardless of whether you think you have it or you don't have it. I'll decide when you have this stuff figured out. I'll tell you when you can stop doing problems. Until then, you got to do all these problems that I'm giving you here today. So this is the difference of 2 squares. So we're going to go ahead and factor that. What number times itself is equal to 1? Obviously that would just be 1, and you put your plus and minus sign. That's a good point I want to make, is that a lot of students will say, well, I think I can stop I think I've had enough of these problems. I think I've got it. Well, again, I'll tell you when you've got it. You need to do all the problems that I do here and all the homework, and then you're gonna have enough to be able to do these problems. You won't be able to do every single type of problem because there are so many different variations, but you'll be able to do the core curriculum problems, and that's what I give you is the minimum that you need to have the tools to figure out the problems. All right, so everything looks right. So now, as you can see, I don't really have much room, so I'm just going to skip a step and write x is equal to 2. Well, that's no good because you can't even read that. X is equal to 2, x is equal to -1, x is equal to 1. All right, so why don't you try number 35, and when you come back, we'll do it together. All right, we're back. So we're going to have to put everything on the right side of the equation to keep this a positive coefficient. And I'm going to move this over a little bit. And this is going to be factoring by grouping, obviously. And we're going to factor out a 3y minus 5. And I'm going to break it up. So this down here is going to lead to 5/3 as a solution. But over here, we're going to end up, if we isolate the square, we're going to end up with -3/2. And a squared number cannot be equal to a negative. So this does not lead to a solution because it's the sum of two squares. Not two perfect squares, but the sum of two squares. So if you got that answer, good job. Again, the only difference with these problems is that we have to put everything on one side first, and be sure to put everything in descending order of powers. Notice that I put everything in descending order. I haven't stated that clearly enough, or more. I haven't stated often enough. You have to write it in descending order of powers, or else it's going to be extremely difficult to factor. So just be aware of that. All right, so now we've got 6 easy problems. So that's going to be good news for you. These are not hard problems, but these are problems that students have a lot of trouble with, even though they're really easy. And I think the reason that people have students have problems with these equations is because for some reason these types of equations, they kind of just fall through the cracks. A lot of teachers forget to teach this type of equation, so students don't know what to do when they see this. They think you have to use some difficult method, but in these equations, all you have to do is just factor out a greatest common factor, and then you're done with the factoring process. So what we're going to do is we're going to factor out a greatest common factor, and then that's all we have to do. Now we see the solutions. Now you break it up into two parts, and we have x is equal to 0, or x plus 5 is equal to 0, which means obviously that x is equal to -5. That's it. But like I said, a lot of times these particular types of problems are not covered in high school, and so when students see this, they don't realize how easy it is. I've worked with many high school students and college students, and when they see this, they just don't know what to do. Because again, it's just something that is not taught very often. So that problem is really easy because when you factor out, you're not left with a quadratic expression or the difference of two squares. You're just left with a simple binomial, and that's why it's so easy to solve. So let's do one more of these. This is a problem where we have to put everything on one side of the equation first. It's easiest to put everything on the left side of the equation. And remember, you got to have your powers in descending order. That makes everything easy. So now we just factor out the greatest common factor, which is going to be 6x. And we get 18x squared if we multiply back, and negative 42x. So it looks like that's correct. But again, you see how easy this is? We don't have to factor anymore. We're done. We just have to look at the answers. 6x can be equal to 0, which means that x is equal to 0. And, 3x minus 7 is equal to 0, which means that x is equal to 7/3. So there you go. So let's see. Why don't you try number 38? 38 is going to be like 36. So go ahead and try that, and when you're done, we'll do it together. All right, we're back. We're going to factor out a 3x squared, and we end up with 1 plus 5x, it looks like. Multiply back, just make sure we did it correctly. That looks correct. So now we're done factoring. We just break it up and we say 3x squared is equal to 0, or 1 plus 5x is equal to 0. X is equal to 0. And in this problem, it looks a little different. But we're just going to subtract 1 from both sides and divide both sides by 5, and we get negative 1/5. So no big deal. So if you got those answers, good job. If this confused you because the 5x and the 1 were switched, don't worry about that. It's just a different variation of the type of problems. We're going to subtract 1 from both sides and divide both sides by 5. So if you got those answers, good job. Now try 39. Remember, you have to put everything on one side of the equation first, and the easiest way to do it is put everything on the right side of the equation. If you put everything on the left side of the equation, you're going to end up with a negative coefficient on the first term, then you're going to have to factor out a negative. So try number 39. When you come back, we'll do it together. All right, we're back. So I'm going to subtract 20x from both sides. And then I'm going to factor out 10x. And then I'm going, oh, whoops, I forgot to put my 0. Don't forget to put your zeros. That was a bad mistake that I just made, because a lot of students like to do that. 10x equals 0. X equals 0, so that's one solution. And x minus 2 is equal to 0. X is equal to 2. So if you got x equals 0 and x equals 2, good job. On to the next problem. So these are the last two problems. So this is kind of a long class. I'm sorry about that. But this is really good practice in solving equations and also factoring. So in this case, you can just leave this expression, but you can just factor out a common monomial, or you can put everything on the left side, change the signs to positive. We don't have descending order of powers. It's mixed up. But when you have two terms, it's not really as important as when you have 3 terms. So you don't really have to write in descending order of powers. So go ahead and try number 40, and when you come back, we'll do it together. All right, we're back. So I'm just going to go ahead and leave it like it is. And again, when you have 2 terms, it's not really that important to write in descending order of powers. It's really when you have 3 terms or 4 terms that it's important. So I'm going to factor out a negative 2x, and then we have 4 plus x. I think that's correct. Yes, that's correct. And so now that tells us that there are 2 solutions. negative 4 and 0. Divide both sides by negative 2. You get 0, and subtract 4 from both sides, you get negative 4. So if you got those solutions, good job. We have one more problem. If you've made it this far, I'm proud of you. So the easiest way to do this is to, well, you can do it any way you want. Go ahead and try 41. Remember, we can't have a negative on the leading coefficient, so you're going to have to factor out that negative. Actually, in these problems, I don't even think it really matters, to be honest with you. It's really just when you have the difference of two squares, you have to make sure the leading coefficient is not negative, and even more so with trinomial quadratics. So try 41, and when you come back, we'll do it together. All right, we're back. I'm going to go ahead and just put everything on the right side with descending order of powers. That's the safest way to do it. Just looks more familiar that way. So I added 11x cubed to both sides. And now we're going to factor out the greatest common factor. And break it up. So x is equal to negative 4. And of course, it doesn't matter what the monomial looks like, as long as it has a variable in it. It's going to lead to a solution of 0. So if you got those two solutions, good job. So that was the class today. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Now, don't go before you get your homework. Take a screenshot of these two pages. Make sure to get that homework done completely, correctly, neatly, and keep it in order in your binder. Remember, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in the entire course. So get that homework done, and I'll look forward to seeing you in the next class.